Okay, I'm here continuing the discussion of optical fiber types. We just finished talking about multimode fibers, and in this video what I'll do is I will talk about single mode fibers, and I'll talk about 3 different SMF28 varieties, and I'll also talk about clear curve SM. Leaf and Vascade fibers will come in, probably come in the next video. So if we're talking single mode fibers, the most famous single mode fiber out there is Corning's SMF28. SMF28. And it's been around for many years, and it's gotten better and better over the years, and there are 3 different varieties currently available as of summer 2012 on their website. And these 3 different varieties of SMF28 are the SMF28 Ultra Low Loss, the ULL, and then there are 2 varieties labeled with E+, and the E+ means that the water peak has been effectively removed and that there is actually a specification for the maximum loss at the water peak wavelength, and that these fibers are then billed for coarse WDM systems, which have to use wavelengths throughout the whole 1310 to 1550 range. I'll show you these specs. Finally, clear curve single mode. In the last video we talked about the clear curve fiber, the multimode fiber, and I explained how they have this nanotechnology technique for recapturing the mode in the core if some energy has been lost into the core, into the cladding, using this mirrored structure. And basically they do the same thing for clear curve SM. So clear curve SM has that enhanced bend performance. So I will leave that as the extent of the discussion for the clear curve SM. The E+ varieties have a reduced water peak spec, and sometimes they're called full range fibers. Let's see, what are they called? Full range. Good for coarse WDM systems where 1300 through 1550 is used. So the full range, let's see, what is it called? Full range, something like that. And then the ultra low loss and the low loss varieties, let's see, the SMF28 gets down to 0.17 to 0.18 dB per kilometer at 1550 nanometers. Okay, so let me go ahead and show you those spec sheets here. Here's the Corning SMF28 ultra low loss optical fiber, and the attenuation is given at 1310, 1550, and 1625. Essentially the spec we're looking at though is this ultra low loss at 1550 in the 0.17 to 0.18 range. This is great low loss fiber, and I think it's essentially selected from their single mode fiber manufacturing as those pieces which are the best. Okay, so the specs also include the attenuation over different bands of the wavelength. Okay, so from 1285 to 1330, 1525 to 1570. Okay, and so when you specify over a band, then you have some variation. These fibers have macro band loss, which is more or less the typical performance. Nothing spectacular here. This is not the clear curve. And we're also given specs on the cable cutoff wavelength. We already talked about this in that example problem that I did earlier in this chapter. So the cutoff wavelength is near 1250 nanometers, and that gives us good single mode performance at 1550. The mode field diameters are specified. The dispersion is specified with an upper bound. Polarization mode dispersion, something I'll talk about later, is specified as well. And then there's a whole bunch of different dimensional and environmental specs that are given. And I won't go through these on all the fibers. I'll go through them here on this one just to give you an idea. Fiber curl, if you just lay a piece of fiber down on the table, it will naturally curl up into a circle, and it's a greater than or equal to 4 meter radius of curvature. Cladding diameter, core cladding concentricity, how perfect is the cylindrical geometry, and the cladding non-circularity, how good is the geometry here on all of this. Coating diameter, so this is a 125 micron cladding diameter, and that cladding is coated then to 245 microns, or about 1/4 of a millimeter. Okay, and the coating concentricity is given. They give you temperature ranges for the operation of the fiber, humidity and temperature, and also give to you a maximum dB per kilometer variation in the attenuation as you take the fiber over these ranges. So that's the SMF28 ultra low loss. The other versions of the SMF28 include the SM28E Plus, and this fiber, let's see if I can get it to show it for you there. This fiber spec sheet talks about the fiber being ITUT G.652.D compliant. And G.652.D talks about the water peak. And basically what we're looking at here is the maximum attenuation over wavelengths, and you can see here at 1490, and let's see, 1383 I guess is, don't they show a plot of the loss as a function? Hold on. Let me find the plot I want to show to you. Let me show you here the loss as a function of wavelength. Here's the relevant picture from your book. This is figure 5.12 on page 135 of your text, and you can see here that normally we indeed do have the lowest loss at 1550, but we have this OH absorption peak at about 1380 or at about 1400 nanometers. And so, as I said, the G.652D spec, ITU spec, specifies that, and this is that specification at 1383. Okay, and you can see that is the highest loss at 1383, and that's an amazing loss. You know, that's very good, 0.31 dB per kilometer, or 0.35 dB per kilometer. If you compare that to the picture in the book, the picture in the book is showing the absorption peak going up to 2.5 dB per kilometer. Okay, and so this is really amazing. These fibers are getting way down into the 0.2 nanometers per kilometer range at 1550 and down well below 0.5 even at this water peak. So these fibers are much better than what you're seeing shown as sort of legacy standard performance in your textbook. And so cable cutoff, and a lot of the other specs are the same. At 1550 you'll notice that the loss is in the range of 0.19 to 0.2 dB per kilometer. If we move to the SMF28 ultra low loss fiber, SMF28E plus LL, this is the ultra low loss version of the E plus fiber. Okay, so it again is talking about G652D compliance. It again is giving the spec at 1383 where we have the water peak. That's the important one. And then at 1550 here, this is essentially the same fiber as the 28E plus, but it's been selected for low loss. And at 1550 you get 0.18 dB per kilometer of attenuation at a max on this E+. I believe you will pay quite a premium to get the LL version of the E+ fibers because it is selected from the batch to have the lowest loss. Okay, I thought these E+ fibers had a little plot of the attenuation versus wavelength on their sheet, but I guess not. Okay, so that's all I'm going to say in this video. So I've talked about the SMF28 varieties. I talked a little bit about the Clear Curve SM. The Clear Curve SM is called Clear Curve ZBL. This is the single mode version of Clear Curve fiber, and they say it's compatible with the SMF28 varieties. So in the next video I'll come back to leaf and vascade single mode fibers. Thanks.